are 19 parties in conference, including you.
And just do as we say here. We've got a little try to save the project as. All right. What that should do for us, and I'm going to cheat a little less time. I'm just going to copy this out of the data set, or out of the file. Jump to Minitab. Now, we've got all these different files in here. Go ahead and cut and paste this data that I copied from the PowerPoint and work right here. Instead, I'm going to show you guys real quick how to open up a new one. Just go up to File, click on New, a worksheet in a project, and we want to open a new worksheet. Click OK. Now I've got worksheet 22. I'm going to jump to it and my data in there. And notice I have both variable names in the same file. And I'm just listing that. So let me give you guys a couple seconds to go ahead and those values. And like I said, 2, 5, no big. So it's rolling. And what we want to do, I had mentioned before, we're just going to go up to File and select As. And hopefully, the folder that is in the save in is the file name that you put in the default location in the session this morning. Right? If you change it, that file should come up, or that should come up. All right. So I can name this file, or name this worksheet I want to name it as. Click Save, and it went to that location. All right, so that's a little exercise there, practicing. Is generate basic statistics. I'm going to go to that basic stats, that graphical summary that we had mentioned before. So that under stats, enter that first block. The last there is graphical summary. And I click on that guy, and then 2 variable names. And you double click on both of those guys, and they'll jump into the variables cell. Click Select, put them in the cell also. Click OK. And here I have 2 brackets. If you notice here, that line says that if I add more data to the data back here, it'll be updated. So that's the motivation behind putting that little checkbox in the little graph option under the tool. very handy situation here. Look at just for example, points, not a super big data set. Here's a box plot that we mentioned before. Note down here a little bit different. Now we're in that 5% confidence interval. Estimate is 8.9, so that's the average. And the interval is 8.65 to 9.148. All right. So you might question, get these little pop-up boxes. All right. That's one of the things about Minitab. If I hover over something, I can get this little text box that'll tell me something. Here is this is the active window. It's at, in fact, actually overshadow the graph, and I hover over something on the graph, you don't do anything. To get the little pop-up boxes has to be the active window. Things don't show up. The summary information, quartile, the median, the third quartile, the interquartile range. So what they got to 8.6 to 9.1, sample 5. Here's the median and third quartile information, same thing that you would see on this guy. The inner range, that's simply the difference. Oops, and I will show it to you. It's the difference between third quartile and the first quartile. All right, so that's the IQ range. Interquartile range is the IQ range. It's the difference between the third and the first quartile. We said statistics, mean, standard deviation, variance, skewness, kurtosis, and we can talk about this little bit, the Anderson-Darling normality test. The Anderson test tells you whether or not the data that you have, data set, normally distributed. And if it's here, we've got an A squared, which is the Anderson-Darling test statistic, and we value. This value is less than 0.05, that this distribution is not normally distributed. So here, with a 0.336, what we're saying is that you can't say that the distribution is not normally distributed. Kind of that, well, say it's not normally distributed, it must be normally distributed. So it's it is literally a double negative. So it's in circles. It's a double negative. All right. And like the goal summary is your friend. It tells you distribution a lot about your data. Because we'll talk a little bit more about how to actually analyze your data. Steps become just following your data. Make no glares in your data. Another way you do that is to generate like this one that you don't have any mistakes. Now it's here for pressure. My number of 89.1, No big deal. My min versus my max, 8.69.1. Well, suppose I plugged in a value like 80, which should be 8.8, but I missed that number. All right, then. Oh, notice what happened. I now have this there. All right, the worksheet did update for my dandy little point that I added here, even though I did in this guy. So, again, key being to the statistics is see if I've got any nasty outliers in my set. So I'm just going to get that guy. And this little set of 5 variables. All right, so nice little graphical summary. Now I've got a couple variables collected at the same time. What I try to do is say, okay, is there a relationship between those two variables? We can a plot, all right, XY plot to see if there is just a basic relationship of variables, and we can do that under graph, scatter plot, and simple. All right, just for a simple scatter plot, and then we further, and I can use this higher powered technique called linear regression. The linear relationship between those two variables, and I regression and fitted line plot. I can, is there a correlation between those two variables that say maybe as one increases the other increases, or as one increases the other decreases? Is there a consistent pattern between those two variables? And I can do that under basic stats and correlation. Do that. I'm going to start off with, I'm going to say graph, scatter, and I set a simple one. I'm going to say, I've got as my x, y. So I'm going to do pressure as my y and length as my x. I'm just going to click pressure, if the cursor in Minitab automatically increments to the next cell. And OK. And you can simple, painless plug. I hit points, and it tells me which data point that on the plot. Let's see, is the fact that there is one point that's actually a double. And so with points 1, 2, 3, and 4 with a 5th point. Right? So then we can adjust options if we wanted to hide that overlapped data point. I'm here to graph, scatter, and I want to see if there's a nice line that'll go through that. So instead of the simple like we had before, I'm going to click in with regression. Making me fill this out again. And in X, and again I'm going to put in pressure, length. Now there's out a second time because that's the first time I ran that function. I can go over that line, and Minitab tells me what the regression equation is. All right, pressure is equal to negative 7.958 0.854 times the length. It's got an R squared of 94%. That's a line that'll fit that data. Move away from the line. I have no record of what that equation actually is. So that's a good thing. Before we would actually do the regression, we can go up to stat, regression, and do the line plot. Click on plot, and pressure, double click on pressure because it's my Y, double click on length, that's my X. And I can look at the different types of regression. I can have a simple linear regression. I can have erratic, which says there's some curvature to the line, or cubic, saying that there's actually two inflection points in. I'm going to stand here. I just want a straight line. I'm going to click OK, and B. Same. The scaling on it's a little bit different. It's not as angular as it like in the other plot. I got summary information here. I've got my regression equation up here. Jump over to the session. Here's my regression. Here's my summary statistics that you saw. My nice little table for the analysis of variance. It says my p-value is 0.006. Further, which says that yes, that significant relationship between those two variables. Anything that I had mentioned doing was a little correlation. Jump back here, go to stats, basic stats, and all here correlation. In basic stats, we've got both different stuff that it does. You know, we touched upon the statistics and the graphical summary, but down here correlation, you know, some other t-tests and proportion tests. Now we met and Darling normality test and a graphical summary. Here I can run it separately. I did test for Poisson distribution. This for correlation. And my two variables, pressure and length. Click OK, and rated the correlation with the coefficient 7, and the so it's the very same one that I have up here. Those two numbers match. If you were the suit of the R squared number up here, this 941, 94.1 or 0.41, took this to 0.941 to this 0.97 down here. Between this R squared value and this correlation coefficient down here. The sums, all right, should I put a positive sign in front of this or a negative sign? By the direction of the slope of the line. So the coefficient up here is positive. All right? It tells you what the slope of this line is. Since there's a positive correlation, as length increases, pressure increases. If pressure increased, if length increased and pressure decreased, you'd have a negative coefficient. This would be a negative sign. And here, session window, this coefficient would have a negative sign out in front of it. This will still be a positive number because it essentially is just this squared. So if you multiply a negative value times this up, you get another positive value. So that's why it's positive. And that coefficient, you look to see, or for the coefficient, you just simply can't take root of the r squared. You got it's a positive value or a negative value.
Well, I have a link. This is John Melvin.
So, say a few of these slides already. As I mentioned, if we did the fit plot, our plot looks like this graph put out here, our session window, and regression equation. We've got the summary statistics, the standard error, the standard deviation of the fit, our square value. The adjusted R square value, this takes into account the number of variables in your model. So we've only got one variable in it, length. Analysis of variance table telling us we is explained, or how much of the variability of the system is explained. So the variable we have for the regression length explains 94% of the variability in the system, which is this 0.10 divided by 0.160. So 15/16 is essentially 94% of the variability. Let's explain this variable right here, the length. All right. Looking at the correlation, to get quick, we had correlation coefficient 0.97, p-value 0.006. The closest correlation value goes to 1. Perfect the correlation is between variables. The closer this correlation coefficient is to 0, the closer it is to say that there's no relationship between the variables. And this tombstone down here that says, remember, regardless if you're looking at a correlation coefficient or regression, it's about causation. All right? There's no guarantee that if I look at this model, say that I increase the length of the back on, say, a little hand pump inflating a volleyball or a football, and higher the pressure is for air going into that thing that I'm filling. Right there with that little example, but what I'm saying is that there's no causation in this relationship. I really need to find some way to prove causation. Right now, I can say that the relationship exists. I can say that one causes the other. It's just a relationship exists. All right. Another. All right, a relationship between a couple of variables. We should have a resistance worksheet in Minitab. There. If you hit this middle little icon after you scroll, this guy will give you the list of all the variables or all the worksheets in your set. We want It's not a answer. Double click on rolling resist, and I get a full data set. It's just 5 data points in 2 columns. Sort of thing that I had before. This one is, we tested some tires here in Akron, shipped them off to Korea to the kind of Institute of Standards for Korea, and the same way. Test results. So what I want to do is see what the relationship between these two tests are. So again, what we're going to do is come back up here to stat, regression, do our line plot, and now, all right, which one should be X, which should be the X, and which one should be the Y? All right. Got any ideas on how this should be set up? Which the X, which one should be the Y?
This is Melvin. I should be the dependent variable and X should be the independent variable.
Switch. Is Akron the independent variable and Korea the dependent variable, or is it the other way around?
Can I look at the previous slide to see the question?
Sure.
Well, according to the question, I don't see, it could be anyone. You want to see if there's a dependent, if one's dependent on the other, so it works the other way around.
My line of thinking on it. Perspective, all right. The tires, and we tested them here first, and we want to see how well the Korea lab matched ours. So that would essentially say that we're the main variable, we're the X, and the group is the Y. So what I say, okay, my Y is the Korea is my Akron number. I'm going to say that's what I have. So if you see little regression results here, this is a good regression result. Yes. Okay, it's a good regression result.
The height and the proximity of all the dots to the line.
All right, my R squared is like 99.7. The perfect number would be 100%. So this thing is just like right on top. And like you say, the proximity of the variables, or the dots to the line, they're there too. I mean, they're practically right on all the way across the scale. So you're right. Perfect. Let's move on. Right. Let me a little idea to you. The of enumerative statistics versus analytic statistics. All right. When I got enumerative type statistics, it's descriptics on steroids. All we want to be able to make a statement about the population that you're looking at. And Edwards Deming, he about an study. And the motivation behind the analytic type study was to truly understand a causal mechanism. So what he states here is the fact that you make sure and collect data over time this system to prove causation. It goes back to the statement I was making earlier on. If I just take a single sample, I make a conjecture about a sample, but I really can't make a statement about anything else of the system about performance because I have no idea what the variability of the system is to make a prediction of the future. So to make a prediction, you've got over time to understand the variability of the system better. You may question, well, why is that significant? Let me give you an example. At Akron, or here in Akron, we have chemists being approached by chemical producers, all that they've got the greatest things since sliced bread, crack jack, and Cheetos put together. So, like guys bring stuff in all the time. So they get material from a guy, he tests it out, and he thinks, hey, this stuff is good. What happens next? Well, put in an order for more material, and he does all his lab work and acceptance testing based on sent to him. Stuff, you might say, considered to be the center cut material. Right? So the best because it's a sample, and the guys always say that, we're trying this business, so we've got to make sure and send these guys the best stuff that we have. So, and we really don't understand the ability of material. We know what the endpoints are to that distribution. The stuff in the center of the process works so that we get material, but you don't know what their capability is and how much variability in that material. So be careful of. Most of the stuff that we do today in the realm of a study, all right, a small population that we're looking at, and we'll make a conclusion and prediction about future performance based on small performance, or based on that small population. So we've got to be careful. All right? So to keep in mind that collecting data over time so that you can make predictions on the future. Well, about targeted sampling as a part of process capability when we get to that section in week 1. I'll jump on the soapbox and things you ought to be doing. Right. Just that in mind. Again, is because I'm here in Minitab because it's the sampling and that as you build your databases, you want to make sure and take these into account as you go out and gather your samples to analyze them. Now, how my data practically, graphically, analytically. All right, that's the point that I was trying to make with the 8 into the data set instead of an 8.8. When you get, all right, look at your data practically. You eyeball your data to see what does the data set look like. What happens in Minitab sometimes, if you've got an Excel spreadsheet, some sheet, you might think that you've got a column then as a column. When you read a worksheet in your data, data is the type of data you think that it's supposed to be. So data, And so take a look at the values and make sure that there aren't any glaring outliers. Like I said, in the case of the 88 versus 8.8, if your data set not be possible. So what do instead? Do a couple graphical summary. See if there are any really strange outliers. This way you identify them early before you're crunching numbers, all right? We say practically, graphically, analytically. If I want analysis, let me start crunching some numbers. You're probably going to have to go back, pull out, and then re-crunch your numbers. So from the perspective of eliminating rework, we want to sure and follow these steps as you do numbers. All right, quick one here. This data was actually some data from the lab. This is actually sent up to Akron to analyze. And they had these from a slide or a batch of data. All right, ring tear test. And these 6 values that they got. 264, 210, 162, 280, 265, 284, 254. The question is that 162 outlier is the there. All right, because kind of off are the other values in the data set. Is it an outlier? Let's jump into Minitab for a second. Go to the outlier evaluation worksheet. That's not supposed to come up. Again, click on my second little icon for the worksheet. I want outlier evaluation. I'm going to come to this guy. And this from of data right here. Dix data. So those 7 data points, I guess, in my data set. And what I'm going to rate a plot. So I'm going to come to stat. Excuse me. I want to go box plot. I'm going to do plot. Click OK. Dixon data right in there. I'm going to do this 160 tear data. Do both sets. Click OK. 2 plots for me. That Dixon data, and I include that value at the low end. Shoot, the minimum. Oh yeah, whiskers 162. The value 162. All right, on the whisker of this box plot, fire. All right, so there's that set. If I look at the set, I over this point right here. It says at a value of 2921. Here's 1 degree tear test data. If I look right here, I looks like a crazy, right? It's done all the rest. It's 4 points in front of the decimal place. Here. Well, they started taking the test a little differently. In fact, machine, notice before that point, after everything was recorded in tenths of a unit. Transition point. All right. Know how to that value. They did it now. They had a decimal value in there. when it was recorded, the 4 data points are all 4 numbers in front of the decimal place. We're going to get in here. We're going to switch that number. We're going to put that decimal place where it belongs because I'm the root cause of that entry error. All right. I made the correction to my little plot, my box plot. But I was able to change that data point and so outliers. Notice I'm moving over this asterisk. Nothing is happening. Question: why is nothing happening? Because graph isn't the active window. This parameter is the active window. It's the darker or the blue. I made the active window. I remember those values. Now, hey, that's 210. 62. These guys are now outliers. What's the difference? I added more data in that process. Add data in the process. Regular performance level, the process, these 2 guys turn into outliers. Okay. So again, our handy dandy little box plot. So again, a graph, box plot, simple, in my variable name, and a box plot. Now the outlier would show up as an asterisk or a star outside the box plot. Numbers here. We created a different graphical outlets. Did the plot, did the scatter plot, did a simple linear regression. So we've not only done the graphical technique, but we also get into a little bit of a quantitative technique. All right. Linear regression, whoops, sorry about that. The regression was a graphical technique. It showed the data plotted with the line, but quantitative, we had output on the session window that we can interpret, and that in the case of the admin plot, right, look at our fit of Korea versus Akron. All right, with R squared, we had our regression, we had our standard error here. Would fit, and we would fit because it's. Let me go back. We were anything over 60%. We're saying that we can use it as a control variable. All right, if there is a causation effect with X and the Y. So there is a causation relationship between the Akron score and the Korea score. Well, relationship between the 2 labs. All right. I mean, on one hand, we make the tires, but that causation relationship goes. The value of the tire, or the value of the test characteristic of the tire, is known the relationship between the score from Akron and the score from Korea. Quantitative analytical technique, and then we've got the graphical techniques. Basic graphs, the histogram. The histogram with the graphical. We looked at scatter diagram. We looked at box plots. Pareto charts. We haven't touched on Pareto charts, and we touched on. There's another chart in there that we can do real quick, which is the fishbone diagram. So data for fishbone diagram, we got a data set for Pareto charts, but again, coming up on the hour. So I've got just about 2 minutes to the hour again. Let's take another break after the hour, and we'll jump into the two graphical techniques, the Pareto chart, the cause and effect, or the figure cause and effect diagram, when we come back from the break. Quick, any questions? Questions? Back at 10 after the hour. Thanks.